So today we're going to talk about machine-readable laws and how LLMs can help democratize the New York City administrative code. So in October 2024, in Brasov, Romania, a person fell in front of an oncoming Tesla with another car approaching. Now, this gives the Tesla a choice. Does it stop? Does it hit the person? Does it go into the other car? In the end, the Tesla chose the other car. Now, whether we program a car to hit a pedestrian, hit another car, hit a building, this is a classic question in the responsible driverless car space. But I don't want to talk about how we answer that kind of unanswerable ethical question. What I want to talk about today is how we program those instructions into the robots and the AI in the first place, and who gets to make the decisions about how laws are interpreted for machines. So I specialize in digitalization for the public and third sectors. My background is in tech policy and data analytics. I run an Instagram page at GovTechGal, where I talk about all things GovTech around the world. So you can follow me and check out the stuff that I'm sharing, including my other contact information, which I'll put up again at the end. Also, excuse me, I'm using a remote, and it's a little buggy. Okay, so I think we're living in kind of a unique time. In the past, and I don't need to tell all of you this, but I'm going to start this way anyway, the interpretation of laws was more linear or circular, where policymakers created legislation, public officials and regulators interpreted it for actionable use, courts acted as an arbiter of disputes, and then the cycle starts all over again. But today, we have something else that's happening. We're living in a time where we are increasingly relying on machines to follow human laws and goals, representing a kind of a change in the historic process, because laws, natural language, are written for human interpretation. They rely on judgment, context, and precedent. But right now, we're designing these machines that are going to be following the laws, not just humans. Effectively, we're turning policy into software. And this isn't just happening, in self-driving cars. This is a graph from the Algorithmic Tool Compliance Report. This is the 2023 data. We can see here that New York City adoption of algorithms in the public sector has increased a lot. Since the 2010s, that's about the time we start seeing a lot of algorithms being adopted by different agencies, which are listed down at the bottom. Similar information, the Department of Health and Mental Hygiene using a lot of algorithms, as is the Fire Department of New York. But crucially, in this data set from 2023, and now I know the 2024 data set is out, so there could be some updates, but 72% of agencies didn't report who had designed their algorithm, which I think is really challenging for those of us who are trying to get down to that next level of how are laws being interpreted for the public sector. And I think, we're all experiencing this in real time too. If anyone's gotten a New York State ID in the last several years, you might have used the identity validation software Okta, which is partnering with the New York State DMV to do official identity validation for folks. I think we all know that adding these types of algorithms and AI into our workflows has been really helpful. So it's not like we should not be adding them into our workflows. We just want to be asking the next level question about, who designed this and how is it actually interpreting these public laws. So this brings us to our central question of the presentation. Who gets to decide how the law is coded for robotics and AI? And there's so much discussion in our space about responsible AI and how we can ensure the technologies we develop are ethical, transparent, aligned with societal values, but how we do that is much less clear. And it's really easy to rely on the expertise of the private sector to develop really excellent digital products for use in the public sphere. So we're going to talk about machine readable laws and kind of talk about a framework for how we might start approaching this as responsible data and responsible tech folks. And the way that we're going to do it is we're going to break it down into 3 parts. First, we're going to talk about what is machine readable laws from the framework that I used in order to create the second part, which is my case study, which was building an LLM that can retrieve the New York City administrative text and answer questions about it. And then finally, we'll end with a little, conclusion discussion. Do I actually think LLMs can do this responsibly? What are my takeaways? Kind of what are the next steps? So I hope by the end, we're going to have a clear picture of what's involved in translating the law into a format that AI can interpret. So first, we're going to talk about machine readable laws 101. So there's no single, in this section, we'll talk about, what is machine readable law, why are they challenging, and why should we be getting this right? So there's no single definition of what a machine readable law is. At its most basic, it's just a legal or a policy document that has been structured to allow computers to analyze it. For example, the New York City administrative text is available in an XML file. But that doesn't tell the whole story. And anyone in the room who works with the law knows that the law is not black and white, and just simply having access to the text is not the same as programming a machine to follow it. And of course, crucially, while humans can make decisions in shades of gray, computers really need ones and zeros, black and white. What's the next step that I need to do in order to execute this action? And that poses a real challenge for, things that are as semantically challenging as the law. So I'd like to introduce this Better Rules framework. It's called Better Rules for Law as Code. And for the rest of this presentation, I just want to say that I'm going to try really hard to only talk about code as programmatic code and text as the administrative text, natural language, just to differentiate and definition set. So Better Rules is a New Zealand government initiative to develop a standardized repository of legislation as code. Not dissimilar to websites like AM Legal that provide legal documents in plain language and downloadable formats. But this is for any company to be able to say, well, I would like to make an app that works with the Social Security Administration. Where can I go to get the code that tells me how to make sure that my app is compliant? And this would be a central repository for that. Crucially, this process is not done behind IP and copyright protections. It's done by public stakeholders, policymakers, lawyers, legislative drafters, service designers, and software engineers. It addresses a fundamental challenge in tech that every time somebody's making an app, say to integrate with a public system, they might be reinterpreting the law in their code. So then we might have, 4 or 5 different systems that are interpreting the law differently and creating different outcomes. And then each system needs to be manually changed as the law changes, etc. So instead, Better Rules basically makes an API for legislation to be translated as code. And so this is just a little bit of a timeline of kind of how it works. You start with the legislation, you have the Better Rules convening that, translates the natural language into code and then puts it into the repository. So it works at a very high level. First, you start with the concept models. What are we trying to digitalize? Then we make decision trees. This is the order of operations. So in a car context, first you have to not hit other cars, and then you have to drive the speed limit. And it goes down the order of operations like that. Then the team comes together, writes the rule statement. So bringing both the interpretation and the order of operations together, turning it into code, making the repository. You do the test suites to make sure that it works in the real world. If it doesn't, or even if it does, iterate and go back through the whole process again. And this isn't just happening in the tiny but mighty country of New Zealand. Open Vista is something that folks in the room might be familiar with. It's an open source project using the Better Rules framework to help global governments and international institutions make laws as code. So just to drive everything home from the original example of the Tesla, we know that autopilot is becoming really popular, allowing cars to partially drive themselves. And it's not just Tesla, BMW, and lots of other cars are also using this feature. But what does it really mean to have autopilot? Well, it's essentially a set of rules and laws programmed into the car for it to follow, like speed limits and safely changing lanes. But in addition to that, the cars are using that code combined with machine learning so that they're able to make decisions on the fly, making that initial programming even more essential. But what's actually happening on the back end? So we're going to consider 4 fictional self-driving car brands: Nexmo, a cutting-edge autonomous vehicle company; Voltaic, a previously top electric car brand; Zeddy and ZMW, 2 classy European luxury brands. I had a fun time making those. I hope you can tell. So autopilots are not just the implementation of driving rules and regulations, they're the interpretations of them. And they're coding these interpretations directly into the cars to make them more autonomous. But here's the catch. Public officials can't review or assess this code because it is protected by copyright, intellectual property, trade secrecy, and on and on. So what's the result? Well, at the best result, we have 4 different autopilot systems that work really well and drive cars safely. But because these systems are private interpretations of the law, they could diverge in unexpected ways, and no one outside of the companies can verify if something goes wrong until something has gone wrong. And so we know that the best case scenario isn't always what happens in the real world, because the real world is messy. So perhaps at worst, we have 4 different cars with 4 different responses to challenging situations. Maybe, those were all supposed to happen one by one, but there it is. So maybe Nexmo hits the car or hits the pedestrian, whereas Voltaic hits the car. Vetti goes off the road onto the sidewalk, and ZMW just sits there and freaks out, exacerbating the situation. So what happens if we get it wrong? Well, I think that we are already kind of living in this world. Private companies' code is shaping real-world decisions, and unlike the legal system, the traditional methods for interpreting the law, there aren't clear public interest checks on these new interpretations. We know over-reliance on facial recognition incorrectly identifies people as criminals. Hospital algorithms misappropriate care based on human coded into machine biases. And lack of accountability in these systems creates loss of trust, skepticism of digitalization and digital tools, real risks to people, and legal chaos. And I can say as well, this isn't just a problem for folks like us in the room, it's a problem for companies as well. During my tenure in DC, there was a lot of discussion around responsible AI and privacy laws, and constantly the refrain from companies was, please just tell us what the framework we're supposed to use is to get this right and remove scrutiny. But in fact, there just weren't really any frameworks that people were able to kind of unearth to provide and create into law. So all of this gets to the fundamental part of responsible tech in my presentation, which is if we want better outcomes, we need to start with better rules. And I hope that for folks in the room, whatever else you take out of this talk is that we all in this room have the opportunity to take control of the translation of laws into code. And I think more than anyone else, we in this room should feel empowered to do so as we move forward in our responsible tech and open data work. Okay, everybody doing good? Shake it out, just like, great. That was a lot of information, but now we're gonna get into the fun stuff, which is the actual product that I designed. So I'm going to talk about, just my project overview, kind of why I decided to do what I decided to do, what my methodology was, and then takeaways. So my origin story for working with LLMs and is sort of my first encounter with this Better Rules framework, which was back in the pandemic when we saw a lot of previously analog systems become digitalized very quickly. And then later, while working in DC on public service design, government modernization, responsible tech, I saw this fundamental gap between the push for digitalization and the frameworks to do it responsibly. And then when ChatGPT launched, revolutionizing how we interact with AI and natural language, and I can say ChatGPT can answer questions about the administrative text. I saw a real opportunity to test the intersection of LLMs and the Better Rules framework. I want to say that I am not a machine learning scientist. I am a social scientist and a data analyst. Although this is not the first AI I've ever coded. I previously did a mortgage classification algorithm using TensorFlow. This was something new that I brought into my repertoire because we are living in the age of OpenAI government, which, in case folks haven't heard, OpenAI has launched OpenAI government, which is supposed to be basically what I have created, but with all of the billions of dollars that OpenAI has to allow civil servants to ask the large language models about administrative texts. And for me, I wanted to do it myself and see what we could accomplish without all of that funding, without all of that background. Okay, so my project idea, I'm going to read it right off the screen. I wanted to fine-tune an LLM on the New York City administrative text using the Better Rules framework to make a more accessible, reliable, and efficient retrieval system so that New Yorkers had an open source, citizen-led repository to understand their rights in non-expert language. And we can see from this slide that it was really challenging. Not only could I not download the entire administrative text all in one go, the hierarchical numbering wasn't standardized. I realized that years and years of work went into ChatGPT and all the data that went into training it, and here I am working on like a month's timeline. Fine-tuning can go catastrophically wrong, where the LLM forgets everything that it was trained on, and that LLMs hallucinate. So I learned a lot of stuff really quickly, but in all seriousness, I went into this project with some a priori methods and came out with something a little bit different. So I'll just go over where I started and where I ended as a little project overview. So first, I wanted to digitalize the entire administrative code. I did not. I focused on titles 8, 9, and 10, and I had more at the beginning, but I kept sort of cutting them just for like price and space and all of these different things. I wanted to fine-tune. So for non-expert folks in the room, fine-tuning is when you actually train there's a pre-trained model, and then you train it again on your new data. But as I had mentioned on the previous slide, fine-tuning can go catastrophically wrong, but also it can't be updated once you've done it. So once you've trained the model, if you want to add new data, you have to retrain the model. So because I was only focusing on titles 8, 9, and 10, wanted maybe a little flexibility to add more later. So I decided to do retrieval augmented generation called RAG. So basically what that means is you create a database of information, and then you ask the LLM to go look through the database and pull out the relevant data based on your query. And then the LLM will spit out a unique answer based on the information that it already knows and the information from your database. We'll be talking more about that as we go on. I wanted to provide citations and responses because, as we know, LLMs hallucinate or you get information wrong from ChatGPT. And so I wanted folks to have like a clear way to go and look up the information after the fact. But really, I just, in the end, wanted to generate accurate responses based on the information I provided. And then finally, I wanted to only use open source LLMs, but unfortunately that too was a big challenge for a lot of different reasons that I will talk about as we move forward. Okay, so my pipeline for how I got from the administrative text to being able to query a RAG LLM. I know that there are different levels of technicality in the room. I'm hoping to strike a balance as I talk about my methods, just to keep it high level, but also provide information for folks that, if you wanted to do something like this, what should you keep in mind? Yeah. So sad. Okay, there we go. I have beautiful icons, but they don't seem to be working. And that's fine. Okay. So step 1, which you can't see, is to oh no, it's there. Fantastic. Okay, so the first thing I did was I downloaded the administrative text. Great. Then, so just like humans, LLMs can't take tons and tons of information and remember it and understand it. So you have to break apart the text into smaller pieces called chunks so that the LLM is really only focusing on like sentence level, paragraph level information. You want those chunks to be semantically similar. So I don't want to have the beginning of my chunk talking about, protected classes and the end of my chunk talking about, gun rights. Next, after I chunked all of my information, I generated question and answers based on the chunks. So if the chunk says these are the protected classes in New York City, the question is what are the protected classes in New York City, and then there's an answer that gets generated. And so I use an LLM to do that Q&A. Next, in order to make it machine readable, you need to turn all of that natural language into numbers. It's called embedding. So I embedded all of my text and then stored it in a database. I decided to use ChromaDB because it has metadata filtering, which we'll talk about a little more later. And then after you've stored the information, you can start querying it, which kind of blew my mind after I had gotten to the end of step 5. And I was like, is this it? Can I just go now? And pretty much the answer was yes. So finally, then step 6 is the data retrieval. So you've got the user query, and then the user query goes through the vector embeddings and the database and the chunks, and then all you get on the front end is the LLM giving you a response. So it's pretty cool.
I think there's a question that I have about you.
Oh, yeah. Do you have time for a quick question about...
Yeah, sure.
Did you tokenize when you chunked, or sorry to throw technical words out really fast, but...
Yeah, great. Okay, so just like how humans look at text in sentences and paragraphs, for the computer, it's called a token. That's the unit of measurement as to how it is counting how big each chunk is. So I ran my text through like a token counter so many times because it was really hard actually to get chunks small enough to then put into the models. And I'll talk a little bit more about that as we move on. Okay, so I'm just going to go through these steps and then we will do some takeaways and get to the demo as well. So pre-processing the text, I decided to use a text file and I loaded it into Python. You have access to these other types of files, but for me, the text file had the fewest special characters. And so you can see on the left here, when you load text into your Python editor, it comes out with really crazy stuff and you have to what is called cleaning it. And so you clean it and then it looks like the text on the right. And so that was why I decided to use the .text file, just because it came out with fewer special characters than others. Okay, now we already talked a little bit about text chunking. So I can say that I spent the vast majority of my time doing the chunking part of it, because especially at this time, I was still trying to use open source LLMs, which have a 512 token limit. So the token is the unit of measure, but a lot of my chunks were closer to 1,000 tokens. And so I really had to be creative in how I was breaking apart the text to keep it semantically the same. I can say for folks who might want to be working with the administrative text in the future, I don't know if I would recommend using the text file because, in fact, it only had text delimiters, which made it a little bit more challenging to split apart the different pieces of information. Whereas if you have text and code delimiters, you can see that it has brackets and quotes. You can tell or you can use Python code to break it apart a little bit more easily. So that's just a housekeeping for anyone who'd like to do this.
Just how do you, is it manual, like chunking? Do you just look at the text and you're like, this is contextual or?
So I use the delimiters. So one, care recipient. And so I said, okay, well, everything that has a number with a dot, take all the text before it and split it there, or parentheses A and parentheses. I did some manual chunking as well. Like I would say it's an art, not a science. And so this is ultimately what my data kind of looked like in the end after I had processed it. I talked about metadata filtering earlier. You can see that I really kept all of the title information, chapters, because I wanted to be able to refer to that stuff later. And then you can see as well, all the way on the right, those are my different chunks. You can see that a lot of them start with a very clear delimiter, because that was how I was able to split the text in the first place. Okay, next, I did Q&A generation. I should say that this is not a necessary part of RAG, but I wanted to improve my responses, so I decided to do the question answer generation. Unfortunately, this is where I ended my attempt at using open source because, quite frankly, they were just really bad questions. Let's see, okay. So the open source question was, what type of activity is forbidden in certain parts of the country? Means absolutely nothing. Whereas then I was using Anthropic as Claude 2.7 Sonnet, and it actually gave me a really good question and a really good answer. So that actually was quite disappointing for me, but then you get the good data and it feels really satisfying at the end.
So the actual LLMs are asking the questions and you're answering?
So in this process, it's all LLM. What I can say is that you use LLMs to make the LLM. And so when I put my chunks into the question answer code, and actually on this page, this is a prompt I made for, let's see, restriction to the use of devices, vehicle. I think this was from the public safety title. So I asked Anthropic's Claude to make questions based on these different categories. And then it generated 2 or 3 questions for every chunk. And then I used all those chunks in my database so that the LLM, when I'm actually querying it, and I might not query the same questions that are stored in it, it does have those questions in the background thinking about it. Okay. So after you do the question answer, you have to make embeddings, which I had said earlier were the number representations of the semantic information. And I sorted into ChromaDB, and this is just the graph of what my embeddings look like. And they're clustered in this way because the embeddings are literally semantic representations of the text. So basically, if I have 5 chunks or 15 chunks that talk about guns, those are going to be clustered together on this graph because they're all very similar. And when the LLM is actually looking for information, say I ask it a question about guns, it's looking at those parts of the vector database to bring that text forward. Okay, and then we're ready to query. So before we do the demo, just want to do a little conclusion discussion. So can we use the Better Rules framework with LM development? Yes, but I think we probably need a much bigger team than just me as a developer. And, I think you could probably spend a whole year even just on one title, going through each area and trying to semantically interpret it for the machine. I think as well, it is a little bit hard because you are relying on the AI through a lot of points in the process, even when you've done a lot of stakeholder work in advance. And so, yes, but the answer is I'm not totally sure if we could fully do justice to the framework using these LLMs because they are kind of opaque in the background as to how they're interpreting them. So I learned a lot from doing this project. I do think that it's valuable to continue to really do the framework justice because I think that New Yorkers could really benefit from having an open source place where they could ask, for example, about their rights against their landlord or an employer or, anything like that they know was cared for by people who have an interest in their well-being and not just, the big tech folks who are looking to sell their products and make money. And so I think that we can just, have this at the back of our mind, that we have the opportunity to create these inputs and, as we're working on our future products, try to do that justice. Thank you to different folks who are not in this room. Hamish Fraser, who's the Better Rules kind of founder in New Zealand. He didn't consult specifically on this presentation, but I've chatted with him a bunch of times. Sophie Gibbs-Williams, AIML engineer with NPlan, really helped me when I was just like, why isn't this working? Thank you to New York City OTI, Beta NYC, and to Vikram Oberoi, who unfortunately is not here because he's presenting right now on his city meetings work, but he was the first person that I chatted to about this project. So thank you to all of them. Bibliography, and then finally, time for the demo. Okay. So we won't look at all the dependencies because that's boring. So I've loaded this into Colab. I haven't really made a front end for it yet because I'm still tinkering with it, I would say. You can see from this information that this is sort of where I've accessed my ChromaDB. It's all stored in Google Drive, which is pretty cool. Here are some demo questions. All right, so let's we'll copy this first one. If anyone is really excited as well, we can use a user participants query as well. Quickly, high level over this code. I have two retrieval models in here. This one is my quote unquote open source model. It's not really open source because I've used Facebook to embed and Google to query, but it's free. I've used this prompt template, so I've asked it to provide only information based on the text that I've stored in the database. You can see here, this is where I've got the Facebook model, this is where I've got the Google model. And then we've got some functions, and then all the way down here we have my query. And so now we'll just run it. Google Colab takes a minute just to think about things, to process. While it's querying, we can look at the Anthropic model. So I was able to I'm able to query for just a penny using Anthropic. Oh, great, finished. Okay, so answer question: what are the restrictions on carrying guns in New York City? Answer: rifles and shotguns must be registered with the city, and the person must comply with all applicable storage, registration, and usage regulations. So then potentially, your next query would be, what are the storage requirements for guns in New York City? going a little off book here. I do not know what answer it's going to provide.
You don't have a question?
Oh yeah, go for it.
Not very technical, so forgive me if this I sound really stupid saying this, but in terms, what's the role that what's the front end is up? What would the role of prompt engineering being in kind of usability and understanding the kind of questions we could ask and limitations, especially considering that a lot of people using this aren't going to have technical backgrounds, so they maybe not know how to properly align your questions with how the model exactly works.
So in this context, I would say that the prompt engineering needs to happen on the back end. Anyone can use ChatGPT, right? Because you can ask it, what color is the sky, and it will provide you an answer. And so from my end or from the back end, I definitely want to do more work because, for example, I asked in the question asking part of my model creation, please make sure this is for a non-legal expert. But actually, a lot of the questions that came out were pretty complicated because it's a complicated bit of information. And so I think it would just require more semantic work from on the development side to engineer prompts that were more straightforward and connect them with the pieces of the code that they related to, so that then on the user query side, they could ask a more simple question. Because as we can see, what are the storage requirements for guns in New York City? Well, the person must comply with all applicable storage, transportation usage, and regulations. So some of the questions come out better than others. And then I will say as well that, again, we're using the open source model, which I talked several times, not as good, did not provide as good information. So now we'll scroll down. I had the same prompt for the Anthropic model. I'll just put in that first question again. What are the restrictions? I'll create that. Yeah.
Yeah, I just had a concern about the output.
Yeah.
The first one, and the question related to that concern is, have you considered in a future state cross-referencing the administrative code with the criminal penal law?
Oh yeah.
Just because my job, I'm a product manager in the analytics unit at the Manhattan DA's office, and I saw that in theory that your first question didn't mention pistols, which therefore someone might say, oh, I don't have to register a pistol, but any firearm has to be registered. Sorry to get into the weeds of it, but that's I would it stressed me out a little because I was oh no.
This is the weeds of it, right? This is why this is so challenging. This is why this idea is kind of audacious and a little bit kind of insane for me to approach just by myself.
But I love that you're trying it. I love that we're making it and experimenting with it. Yeah.
So sorry to trigger you again with the scene. So the Anthropic answer is much more detailed, and it's prettier, and I didn't ask it to make the response look like this, and it does mention air pistols, but a lot of times what I've found is because I've asked it to only look at the administrative text, right. To your point, it says, well, based on solely the provided text, I can't provide the deeper context of the answer. One of the most challenging chunks I had was a section that referenced tons of clauses of the US legal code, and it was just 120.8, 320.9, etc. And it was this means nothing to me, this means nothing to the LLM. I don't want to delete it because that would affect the integrity of the initial data. So yes, having more aspects of the code I think would make the querying more accurate, but then of course you get into the storage and it cost me about $15 to make 7,000 questions off of 7,000 chunks. And those 7,000 chunks were only in 3 titles. So imagine if we were doing, the whole code or how the whole text and how that would look. I have more questions. Oh yeah, go ahead.
Actually, what is the size of the code when it's fully downloaded? The reason for the question is there's actually a movement away from RAG these days because of the larger context windows.
Yeah.
Gemini has a 1 million token context window at this point. You could just dump everything in there. It's 3,000 pages of text. So what is the code's length?
I think it was about, I don't know because I never actually successfully downloaded it as I was trying, but I think that it was like 30 gigabytes was what it was trying to download of all the titles. And that was in the .text. So it might be different sizes depending on what file format you were using.
Would you be able to do a follow prompt and ask the LLM to provide a section of that code and then you can go and do your cross-referencing on your own?
I still need to work with my metadata filtering. In theory, yes, because I stored all of that information in it. I actually did query the code on a similar, so what does Title 8 say about protected classes? So the question I asked it yesterday was, what is Title 10 section or chapter 5 say? And it kind of just said, I'm not sure where that information is coming from because I think that I haven't quite loaded the metadata into it correctly to get it filtered in the way that I want. Yeah, so based on Title 8 prohibits discrimination based on individuals' employment status. So actually, that's a okay answer in terms of not something I would want to send somebody off in the world with, but for research purposes, how did it, process that question?
So how, I don't know if you know the answer to this, but like, how would you have like the better rules framework in this code?
Yeah.
Where would you put it? Like,
It would be at the very start in the kind of chunking process. So in the text and chunking process. So a lot of times, as we're discussing, like the code is only the legal text is only as valuable as the semantics around it. And so the LLM is struggling to give rich answers because I've asked it only to look at the very basic legal text, where actually what probably we would need is like case law, U.S. code expert, or U.S. Administrative text experts, civil servants, third sector folks, all coming together and saying like, okay, so for protected classes, this is what it says specifically, but what are some legal cases that have been decided that maybe go slightly beyond the very dry basic semantics of what it says protected classes are? And then you could turn that into a question that you would store in the model. You could turn that into another document that you stored in the database. So you just say like, this is the information about protected classes from what the administrative text says. Then secondarily, this is what like other case law says about protected classes. And then tertiarily, like this is what the most basic like black and white ones and zeros mean. Can you be discriminated for this? Can you not be discriminated for on this?
so the framework would specify that these are like the minimum requirements of an answer kind of thing?
I think really what it would be is that the framework would create the answers and then we would store them in the back end of the querying.
Yeah.
Either way, there are 3 questions right there, so I point in that direction.
Okay. So I'm going to ask a question and then clarify why that question came for me. So the question is, do LLMs like this, maybe the one that you're building or ones that you probably vision for the future, right? Can it kind of like differentiate between the letter of the law, the spirit of the law? Mm-hmm. And the reason I'm asking that is I'm thinking about the problem formulation aspects of LLM models in the future. What would the goal state be and how you would kind of help it to get the spirit of the law as well?
I think this is the part of the reason why I ventured on this path, because if you ask ChatGPT or Perplexity information about laws, it is actually trying to tell you more about the spirit of the law than just the actual text. And so then we get back to that central question of who gets to be in charge of that interpretation for folks. And right now, it's a little bit OpenAI. And so, yeah, so that would be something that would be the thing that would make this product valuable, I think, is to have that interpretation. Yeah.
Yeah. If you wanted to make this tool more accessible to different reading levels, let's say, talking about just Google who don't have. Just very simply, is there more input that has to happen on the back end to make that happen, or as it is right now, could that kind of accommodate that?
Haven't tested it. I think probably you could engineer a prompt like in this part of my prompt where I say, like, if it's not a complete sentence or something, try to find the keywords and unearth an answer related to those keywords. I think as well, from the back end side, I'm not an expert on like English as a second language and things like that, but there are different LLMs that have different languages. So potentially you could have, you could query it in Spanish if you use the right model. And then in terms of like questions that weren't, academic level or even just, English as a first language level. It's
They knew or
yeah. I would say very likely you would need to work on that on the back end so that it was able to connect the question that didn't have maybe all the specifics with the data that it has stored within it.
That's really and then get.
Yeah, this is really cool, first of all. It seems like the primary mode of interaction for this is question answer, which, obviously that's a very small use case. And I'm also wondering, like, if we had a machine readable digestion of the administrative code and like kind of like we're able to format this as like a hierarchy or like kind of figure out the interdependency between the law, like can you envision other ways that this system could be useful with people working in their
Yeah, definitely. I mean, I think the idea is if you have a like an AM legal for laws as programmatic code, then you can make any type of application you want, and that you've done something that is legally compliant, and that isn't just your lawyer's interpretation of the law in your room in your private company. So yeah, I think the opportunities are kind of endless, from just the New York State DMV application to being able to understand your rights better. When I first was chatting with OTI about this idea, the gentleman I spoke with said, gosh, I wish I had something like this for my job every day. And so, being able to be responsible, civic tech minded when we create something like this, I think could actually be really helpful for folks in government. Yeah, Rina.
So during the process where you use chunks for LLM to generate questions, in this RAG application, how do you draw a connection between questions and the chunk? Do you embed questions as part of the metadata for the chunks?
Yeah. So one thing I didn't say is that the LLM can only understand embeddings, basically. So it needs the numbers. So I embedded the questions and I embedded the text chunks. And then part of the reason that I have this this BART model, Facebook BART model here, is because actually the query that I'm writing is also creating an embedding. So when I ask it about protected classes, it's embedding the protected class word, looking for the same embedding of protected class in the database, because it will be, the same numbers or very similar numbers. And that's how it is drawing the connection between my query and the information stored within it.
Has it ever hallucinated?
I mean, kind of. Is it hallucination if it's just kind of wrong or gives a bad answer? Like sometimes I'll ask it a question and it will say, like, it will just sort of repeat. One of the questions I have is, what are the requirements for a lactation room? or that was one of the ones I was asking as I was testing, and it just said, you know, the requirements for a lactation room are the requirements for a lactation room, kind of.
I'm sorry. On this question about hallucination, I have a more technical question, and I just want to have this by saying that, like, I'm a student and I'm taking a class that's called Law and Large Language Models, and in that class, we're the professor who designs like a tool that's similar to this, but using like not like I guess the whole legal or an iterative code. What she did was like to like spin out for the code of hallucination. Like he would try what you mentioned earlier about like the tokens and embeddings. They would use like the cosine similarities or something to like trap. Besides just earlier, someone else in the audience mentioned like cross referencing, seeing like the citation of like the legal text. I guess I'm wondering, like, is that something, how are you considering, like, safeguarding against the hallucination when you are, like, designing future iterations of this?
Yeah, so anyone who's worked with LMs in the room, like, there are a lot of ways that you can try to test for hallucinations, like, yeah, the cosine similarity and these types of things. Ultimately, these things are just statistics, right? It's looking for, and you probably know more about this than I do because I have not personally taken a class on cosine similarity, but you know, it's looking for chunks that are the same information, or sorry, the same type of information, and that's helpful all the way up until the point where it's not helpful anymore, because it could say that these things are similar when they're not, or the embeddings look similar, but actually, like, for example, sorry, I'm not actually being very specific, but here's the specific one. When you have a small chunk, say it's just a covered relative, the definition of a covered relative is X, but you have a large chunk with lots and lots of text, it's going to create an embedding that is the same length because it needs to have chunks be all the same size. So if I'm looking for cosine similarity between lots of chunks that have very, very small text in them, so all these definition questions, it's going to say that all of these chunks are really similar because most of that embedding is just blank, because it needed to provide an embedding worth of, 1,024 tokens, and actually it's only 10 tokens long. So I think the tools for trying to figure out hallucinations are challenging, and one thing that I really learned is just that it's really impossible as a human being actually to just look at every single component or to find the like linchpin test that's going to unearth all of the challenges in the back end of my data. It required a lot of just like iteration, looking at the chunks, trying small bits. I'm sure there are hallucinations somewhere in the back end of my database that I have not seen yet, just because of how hard it is as, a human being to look at every component of what's there. So we have just 3 minutes left. Just so everyone is aware. Yeah.
So besides, you mentioned you have a tool for specific doing embedding. Is that correct?
I mean, I have code. So by the way, all of this code, if you want to go and test it out yourself, you can check out my GitHub. You can download the repo. You can ask it any question you want. So the embedding function, I think, is not. So I embedded as I added it to the database. So that part is not in the code, but basically it was just like when I showed the embedding function in the retrieval part of the model. I used something very similar when I embedded the model at large, when I embedded the database at large.
Yes.
In the back, yeah.
Just zooming out, just how you kind of like started your career and you talk about kind of high level policy is a really tough fight for any cops. How do we standardize this, across government agencies or any region there? You have any thoughts about that?
Yeah, I mean, I think that the cool thing is that some of this framework component has already been done through the Better Rules work. There's like an official New Zealand government website about it. There's the Open Fiscus stuff. France has done this with their tax tax policies. So in terms of standardizing, I mean, it is a challenging question. Probably a lot of us in the room have worked with government and know that this sort of cross-functional thing is not government's best, most easy role. But I think, you just start with a lab. You start with one law, one policy, and you do it one thing at a time, whether it's identification rules, whether it's the administrative text. And then if you have one law, you have one thing in your repository, and then you do the second law. And hopefully you have stakeholders in government who are building tools that can then use that code and move it forward. So that would be my answer to that. And I have just been told that it is now time up.